Slide, we're going to focus first with Han. Han is solving these three quadratics. We know they're different because one of them is equal to 0, one of them is equal to -1, one of them is equal to -4. Okay? So for the first one, who can raise their hands? This one right here. Who can raise their hand and tell me what the zeros are? Ava? Yeah, it's 5 and 3. And we know that because the zero product property, either way, 0 times anything is 0. So, like Kai showed us in the warm-up, this second one is a little different because we can't get it to equal 0 by getting either one to equal 0 because it's equal to -1. So how would we get rid of that -1? Well, you subtract the -1, which is the same thing as adding 1. You guys vibing with that? If I had this, if I add 1 to both sides, it gets rid of that one. You guys follow that? And that's how Hans got this new graph right here. This new function. It's the same function, just instead of being equal to -1, it's equal to 0. And we want it equal to 0 because the x-intercepts happen when y is 0. Now, if I'm adding 1 to the left side, what do you think is going to happen to the graph? I want you to make a prediction to your neighbor. If I'm adding 1, what's it going to do to my graph? Make a prediction to a neighbor. So let's take a look at all the stuff that Han was doing. So there was a equals -1, so we added that 1 to both sides, and then we ended up with x minus 3. Was it x minus 5?
Yeah.
And then plus 1. And so I heard it out there. I heard some people saying it'd shift up. It shifted up 1. So when we had the previous x minus 3, x minus 5 equals 0, how many solutions were there? The first function. There were 2, 3 and 5. I shifted this up once, and notice, where is our vertex now? 4, 0. It's on the x-axis. How many solutions are there to this? There's 1 solution. So looking at Han's next piece, which is right here. Okay? See that -4 on the right? How are we going to get rid of that -4? Adding 4. So if adding 1 shifted us up 1, adding 4 is going to shift us up 4. So I want you to turn and tell a neighbor a prediction of how many solutions if we add 4 to both sides next. Test it out. So to get rid of that -4 on the right, we're going to add 4 to both sides. Whoa, I did something wrong. Okay. Boom. Shifted the whole thing up. And what do you notice? How many times is it across the x-axis? 0. How could I keep the same parabola but only change one thing and get it to cross twice? Any ideas? Murph? I can put something right here. What do you think, Ryan? Negative. Check it. Boom. Now it's got 2, but that's just for fun. So it's pointing up. The vertex is above the x. It will never cross it, ever. Doesn't mean it isn't a parabola. It just means there's no solution for an x-intercept. All right? So the big idea, as we look back at our presentation, the big idea is every one of these becomes graphable in Desmos if we get the right side to equal 0. Why do we want it to equal 0?
So we can find the x.
Because the x-intercept happens when y is 0. Big. It's like back to that big idea. We had the x-intercept idea with linear functions way back in the day now. Okay? Same big idea. So I want you to practice. Say how many solutions and what they are with a partner. 1 through 3, you should not use graphing technology. 4 through 6, you can. Problem number 1, who can tell me what they did to isolate the variable? What did you do to isolate the variable? Problem number 1, Ari. 11 and -11.
Wait, what?
There's 2 answers.
How?
Okay.
Negative.
Yeah, 11 times 11 and -11 times -11 both equal 121. Okay, so problem number 2. The way I looked at it was I had 31 to both sides to say I need x squared to equal 36, which means x is both 6 and -6. 2 answers. Okay. And number 3, how many answers?
I actually said one.
One answer, x equals 4. It's the only thing that makes both of these 0, or either one 0. Okay? We're going to jump down to number 5 before going to decimals. Number 5, even if I didn't use decimals, I would take the square roots of both sides. Right? And what's the square root of a negative? No. There is no square root of a negative. There's no solution. You can't do like something 2 times 2 or negative 2 times negative 2. Neither one of those would give you a negative 4. There's no solution. So, like Ivy found out when typing in decimals, there's no parabola on decimals. There's nothing there. Because you cannot take the square root of a negative. Until you learn about imaginary numbers. But we're not there. Okay? So number 4 and number 5, we're going to go graph in decimals. But I want a little help getting number 4 decimals ready.
I actually said decimals 3.
So who can tell me what I've got to do to get this decimals ready? JP?
Subtract.
Yeah, subtract 5 from both sides. So,
Your name is not Jacob.
and friends, this works. Oops. This works because the x-intercept happens when y is 0. Which means for number 6, I would rewrite as x minus 4, x minus 1 minus 990 equals 0. All right? So we'll head to decimals here in a second. Yeah, Murph.
For number
So who can tell me what we wrote down for number 4? Sean? Okay, so x minus 1. Okay. So remember, this 5 was on the right. We got it to equal 0 so we can find x-intercepts. And we get the answers 2 and negative 4. All right, and that last one. Who can read that off to me? Ryan? No, right. Yeah, no, read off the function. X minus 4. And so then we did minus 990 to set it equal to 0, right? And if you zoom out, we've got 34 and negative 29. So big idea is we need to make it set equal to 0 because when the x-intercepts happen, when y is 0.
I tried the equation where I just as this and it still works.
Yeah, that's cool. So you need to look at what Priya did and what Diego did and May and see who's right and why. So 1 and 2, analyze the errors made by Priya, Diego, and May, our math friends. Let's take a vote. Who thinks Priya is on track? Who thinks Priya is off track?
Off track.
Okay. All right, Meredith, how do you know what Priya did is not right? Meredith, how do you know that what Priya did is not right? Yeah, so this thing times this thing needs to equal 12. We've got that appropriately pointed out. I think Priya's thinking this is equal to 0, right? And the product property let us make either one equal to 0. I think that's what Priya did, okay? So that is, if we wanted to solve this, we would need to scooch the 7 over to the other side. Set it equal to 0. Now we have x-intercepts ready to rock. So that's where Priya went wrong. She was using the 0 product property kind of extension. Now, I like what Diego does. What Diego does works mathematically. Diego divided both sides by x, divided by the variable, which gave us x minus 10 equals 0. The challenge with this is this only pumps out one answer, right? 10. If we looked at the factored form, how many answers is the factored form saying we have?
2.
Yeah, we lost that divide by x.
I think he's just smart enough to know.
I think it's cool that it works, but we lose an answer that way. So we're not going to divide by a variable when we want to factor something. We're going to write it in factored form, which is going to be less than 6. We'll do more of this less than 6. So 2 answers, not 1. But Diego is trying cool things. I'm going to let you know. I'm pretty sure Diego aces tests. He makes good mistakes on the lessons, and he understands. He tries things, adjust. I think Diego's got solid A, I can tell you. I already know.
I already know Diego.
You're going to try the cool down next. Here we go. Do it to it. On number 1, how many solutions?
2.
None. We can't square something and get a negative.
Yeah, I said
If it was x squared equals 16, 2 answers. We can't take the square root and get a negative. Problem number 2, how many?
2.
Yeah, 0, negative 2. We have 2. And problem number 3?
1.
1. Just one x-intercept of 3. There we go.